and that's it. So it doesn't really tell. I don't know why. Usually it actually announces, but maybe it's somewhere in settings. So anyways, looks like we looked at section 2 of chapter 4 last time that talks about numbers written in different bases, right? So we looked at base 2 numbers, and that's what we were supposed to do on the quiz. So let me start out with a quiz exercise. I believe I asked you to write number 5 given in the base 2. So you can put this little number 2 instead of writing the word 2. It's pretty much same thing as actually not number 5. I believe it was something else, right? 5 was the answer. Yeah, I remember. I think the question was 101. Yeah, thank you. So that was quiz. See, I already forgot. See, time passes by and I forget things. So if you have 101 in the base 2, it means that we deal with powers of 2. So the powers of 2 will be, of course, starting with 2 to the power of 0. Then we have next term 2 to the power of 1, and then 2 to the power of 2. I say, Alex, what about 2 to the power of 3? Yes, there is also 2 to the power of 3, but since we have only 3 digits, then we don't need it. So first digit is 1, so that's the one here. Second digit is 0, that's the one here, 0. And the third digit again is 1, so that's the one here. And of course, these pieces are all added. That's how we perform this process. And now we're gonna calculate and see what is coming out. So when I calculate 2 squared times 1, which is gonna be 4 times 1 or just 4, the next piece will be 0, because 0 times 2 is 0. And finally, 1 times 1 is gonna be equal to 1. I say, why isn't that 2? Well, because 2 to the power of 0 is 1. So you actually do multiply number 1 by another number 1 and you get 1. So when you add these together, you get 5. So you write number in the base 2. In fact, here's the little table that converts everything to base 2 up to 20. And I can try to put something in a base 2 from this table, or maybe just go back with 5. So how do I write 5 in a base 2? Well, first of all, I look at the powers of 2 that are available, say 2 cubed, which is 8. It's too big for 5, it's bigger, so I don't use it. 2 squared and 2 to the first and 2 to the power of 0, right? Those are ones that I will use for this situation, looks like. So finally 2 to the power of 0, which is 1. So I start with the largest number that fits, and that'd be 4. So it looks like if I divide 5 by 4, I get 1, 4. So 4 will go once, plus what will remain is just number 1, right? So I use this first piece. And now the other piece is just number 1, which is 2 to the power of 0. So now how do I write this 5 with powers of 2? Well, looks like instead of 4, I put 2 squared. Now, please notice that we don't have a number 2 here at all. So what I multiplied by was 0, because there is no 2 squares present. So there is one, oh, sorry, no 2 to the first present, right? There is 1 2 squared. And finally, the last will be 0 power of 2, which is 1, and it appears here once. So for base 2 presentation, you can only have digits 0 or 1. And that's another important little fact to realize. So when you write your number in a base 2, so I put base 2 to make sure we know what it is, we use digits only 0 and 1. Let me try another one. So let me try to write 21 in the base 2. Some people will say, oh, Alex, if this was the previous number, then 101, and then there'd be a 0, 1 rather than 0, because that's the next digit. Well, let's check it out, if that's going to work. So turns out that if you're dealing with number 21, you're gonna again need to write this with powers of 2, and notice that to the power of 4, which is 16, is going to fit into this number. You see, 16. So I can break this as a 16 plus, when you say that's going to be plus 5, Alex. Yes, and notice that we just worked out 5. So notice that the next piece I could possibly use is 8, but 5 is not large enough. So I have 4 here present, and finally plus 1. So the point of story, right? This 21 with various powers of 2, such as 16, 8, well, there is no 8, 4, 2, and then finally 0 power of 2, which is 1. And now we'll see what powers are missing, such as a cube, which is 8, and first power, which is 2. They're missing. So I'm going to now rewrite this as 2 to the power of 4 instead of 16. Then there'd be 2 squared instead of 4, and 2 to the power of 0 instead of 1. So these will be multiplied by 1 because they are present. Please notice again, you can multiply them only by either 0 or 1, and that's it. Because base 2 only uses zeros or ones, right? And then there are missing powers that are multiplied by 0. So missing powers of 2, of course. And there are, looks like 2 of them. It's a third power of 2 and the first power of 2. So I put 2 cubed times 0 and 2 to the first times 0. And now all I care about is just these first digits, because powers of 2 are not being shown in our number base 2, but just digits they're multiplied by. So I get 1, 0, 0. And yes, looks like we do have that. So when one looks at these digits, you can see how they've been increased. So first is 0, next is 1. Now I run out of digits. So I put the second position, and on it I start with 1. So first possibility is 0, and second possibility is 1. So that's the next possibility. So once I ran out of all possibilities with 1 and 0, now I have to use the third position. And again, I put 1 on it, and then keep those 2 as zeros. Notice that the remaining portion, let me highlight this, is going to repeat here, just like it did there. You see? So technically, all you do is just put 1 in front of all of them. You see how it works? Now, this whole story, all of these 8 digits, let me put them different color, red. All these 8 possible numbers will appear here once again with a first digit 1. You see? They're exact same 8. 1, 2, 3, 4, 5, 6, 7, 8. And so forth. So basically, they doubled. So on the next stage, when you put 1 in front, you're gonna get previous 16 attached to it. So the number of those base 2 writings always going to double when you attach another one in front. So I guess really have to think of it this way, but it's worth to, especially if you're planning to take some computer science classes, look at it and maybe get used to it. And I would say look at base 2 numbers, because once you start to get used to them, then all other bases are really the same, really are the same. Yes, they look bit unusual, so some people just try to grasp the whole thing at once and shut down and say, oh, I have no idea what this. So no, just look at the way we produce these numbers, and it's nothing else but some coefficients with powers of 2, and that's really all it is. And I do realize it's a little bit confusing, and I am willing to make all kinds of adjustments on people taking quizzes and things. And what I would say is I'm willing to give some extra credit here in this class. And I think it's always helpful, especially to those people that take class seriously. So what be for the extra credit? So we have the exercises that assign for homework. And if you look at the page that refers to this section, then you notice that there are only one column of problems called practice exercises, right? So you should try for homework everything that is on the first column, and you don't need to worry about this practice plus or application exercises for the homework. You can do them, of course, and you can ask me to do them. It's fine, absolutely fine, but you don't have to do them for homework. So I don't assign them. But if somebody does, then it's absolutely okay with me. You can do it for, let's say, extra credit. If you did not perform well on the quiz or miss the quiz, usually that's what happens. People just miss the quiz for various reasons. Maybe it was not your fault. Maybe computer shut down or cell phones lost power or something. Well, then you missed the quiz. So that's fine. You can always make it up. So how can you make up for the quiz? Well, since I assign you to do, let me clean all that mess I produced first. Let me share my screen again. So since I assign you to do problems from this practice exercises, and I ask you to do odd numbered problems, right? What you can do for extra credit will be even problems. So extra credit is even problem. So if you do even exercise, you can make up for your quiz. How does that sound? So let's say on this quiz, you didn't get what is the answer, 5. You got something else. Okay, you can fix that. You could just do one even exercise from this section, whichever one you prefer. I'm not going to tell you do number 17, because one say, oh, that's base 16, Alex, you've given us bad problem on purpose. You don't like that 17, fine. You can just, oh, actually that's odd numbers. I'm not going to say do 16 or you can select any one of these even problems that you like, okay? And do it. And if you have difficulty to select, okay, I can select it for you. Do number 20, okay? So if you want, do number 20. If you don't like 20, well, then do something else. Select one problem which is even, do it over weekend, and email it to me. But what's very important, right? This is my extra credit, and I'm in 1107 class. I need to know where you are, because otherwise, I got 5 classes. It's very difficult to keep track of who is in what class, and so it takes you what the extra second to write that, right? So please, whenever you write some extra credit problems, first of all, I accept it anytime. So any moment you're done with it, you email it to me. Please don't put it on Blackboard or some place and people say, Alex, I went to campus and stuck it under your office door. So don't stick your work under some kind of random doors or some other places. Email it to my email address. And if you forgot my email address, it's in the syllabus, or I will be sending you email today later with this lecture. So you will see what email it comes from. So you don't have to put this in other email systems, but email it directly to me. And again, you send me extra credit work anytime you're done with it. So I don't put any restrictions. I check my email on daily basis. If you send it, of course, to my email address. So please do that. So email address and you can send. And those people that did well on the quiz, it's fine. You can also do it. You can also do extra credit if you feel like it. I'm open for that. Why should I say, okay, this group of people has privilege of doing extra credit and the other doesn't? So why should I punish those that perform well on the quiz? It's not going to be fair, right? So if you did well and you still feel like doing some extra work, sure, I will add it to your quiz scores and you can utilize it for the next time or for final exam if you get maximum. Remember, I told you that there is no limit for extra credit. When I say, so I can do 10 problems, sure. When I say I can do 1,000 of them, absolutely. So if you do 1,000 extra credit problems, you're going to definitely ace this class, that's for sure. But point of story, I give you this chance because I know anything can happen. It could be on my side. It could be that I missed somehow you sent me something, I missed it, I lost it or something. So that's the reason why I know in the online environment that we are in, things happen. And that's the main reason why I give you this opportunity. So you can just, to be on the safe side, do a couple of extra problems. I don't think it's going to take a lot of your time. I say, Alex, I don't want to waste your life on you, my life on you doing this stuff for you. Well, if you want to get a perfect grade, well, do a couple of extra problems. It's going to take what, a few extra minutes. I don't think it's a big deal, right? Just think about it. So yes, various things can happen. It may be my fault, maybe your fault, maybe computer's fault or somebody else's fault. Well, I give you a chance if you feel firmly that you're an A student and you deserve perfect grade in this class, fine, I don't mind. Just do a little extra and I will definitely be more than happy to provide you with a fair grade. But you can do more if you want. If you like this section, then you can do more problems for extra credit. But again, they are even exercises. Some people like to do their homework and say homework are odd problems, right? Every other odd. So they like to do homework and say, Alex, this is my extra credit. Well, that's your homework. That's another part. That's actually 20% of credit. So if you say it's all my extra credit, well, you're not going to get homework credit, right? So that's not a good idea. But do homework, and when you do homework, if you see that you're fine with some odd numbered problems, well, you can do even problem next to it. But please send it to me separately in a separate email so I know that this is your extra credit. That's another part. So you want to make sure that your instructor knows what you're doing, if that's extra credit or that's just a homework, right? So two things. So please, first of all, make sure you tell me what class you're in. And second, tell me if that's extra credit. So extra credit you can send anytime. Homework, don't send right now. It's due in October, right? So I guess that's the way to go. Let's
Professor,
see.
we have to send you the homework too, to your email too.
On October, month of October, when we have a midterm, I will be asking you for homework. Right now, I'm not asking you for that, so don't send it to me. But yes, the only way you can send me your work is, there is no other way. It's online class. So you will send it to me by email on the day of the midterm, all your homework. And believe me, I will be reminding you of that. So I'm not going to forget, and you will not forget. Every day you're in class, I'll tell you about homework due. So you do, question is odd only. So yeah, extra credit is even exercise. So I think it's pretty straightforward. Like even for extra credit is odd, every other odd for the homework. So anyways, glad that I can do this for you, help you with this extra credit opportunity. And now we're gonna go back and I guess just practice more of this little exercise. So actually this is already with everything that you need. So let me first of all clean my messy stuff here so you can have a clear screenshot. So let me clean this a little bit for you. And also I can scroll this down a little bit. Practice, you don't need word practice. Like that. And that's all you need. So just a left column. So you can make a screenshot right now because you're not missing really anything. As if I scroll down a little bit more, there's only one or two exercises left. That's fine. You don't have to do them. You can just, I'll do them for you, in fact. So here's the page, and that's your left column. That's for homework, because again, right column is already under practice plus, so you don't have to worry about this, right? Okay, so since I promised, let me, well, before I convert these numbers to base 7, maybe I can look at some number in the base 7 so we can prepare this a little bit. Is there anything here with base 7? I don't see any problems with base 7. So let me just take some other base and then we'll get there. So maybe I'll try base 8. I think it's pretty close to base 7. So exercise number 11. So yes, there are other bases and they behave pretty much same as base 2. They, I guess, deal with powers of 8. So if you start to think of what they are, as usual, we start with a 0 power. The next will be a square of first power, which is 8 itself, right? Then we have square. 8 times 8 is 64. That's the one I can do without a calculator. But next is going to be a 8 cube, third power of 8. And well, you can multiply 64 by 8 if you want to see what it is. But I have a calculator for this, so I can just get to that calculator and simply raise 8 to the power of 3. So put 8 power 3. And this is 5/12. I can write one more. Why not? This is 512. So what about fourth power of 8? Well, analogously, I can just take 8 to the third and turn it to 8 to the fourth, and that'd be 4096. So fourth power is already 4096. So in the base 8, we have only 8 digits. So we always start with 0. So go 1, 2, 3, 4, 5, 6, and 7. So there is no digit 8. There is no 9. When I say, is there a 10? Yes, there is a 10. But actually 10 means 8. You see what? Well, let's write it down. So let me do it here. 10, again, in the base 8, is going to stand for 1, which is multiplied by, so that's the digit that I multiply by first power of that base. And the other digit is going to be multiplied by, so digit 0 will be multiplied by the other power of this base. And please notice that we add here 8 with a 0, which is just 8. Again, you don't treat this as if it was base 10. It's base 8. So it says 0 of powers of 0, 1 power of 1. And that's it. Let me try another number. Let's try to get something like 1, 2, 3. Basic. Please notice that allowed digits now all go through 7. So I'll be multiplying these 3 digits by powers of 8. And as usual, I start on the right and put 0 power on the first place. Then eight first is here, and 8 squared is here. And you add all of them together, just like that. And then see what comes out. So looks like this is place of ones. This is 8, and this is 64, right? So what we have is 164. So just a 64 here. Plus, now it's 2 times 8, which is 16, right? And finally, 3 times 1, which is 3. So I just have to go ahead and add all of these numbers, and I get 83. I say, Alex, how can I possibly make a relationship with the number you produced here, 1, 2, 3, and 83? Well, this is base 10. There is no relationship that you can logically or intuitively see. It's all with these powers. That's the whole point of this section. You cannot really see how this base 10 number relates to base 8 number. But all explanation is here, so you just write with powers of 8. And you see what coefficient these powers of 8 are multiplied by. Just like that. So let me try a problem. So I'll stop making up my own exercise. So I'll just go back to the textbook and try one from there. So we have something base 8 here, exercise 11. So let me get to it. Actually, notice there are lots of digits here. There's a 0, first, second, third, and fifth power. So notice that I don't have enough. So I need to also present 8 to the power of 5, right? And why don't I calculate this? 8 to the power of 5. So I can change power of 4. I just make sure my cursor is here at the power, and I change it with 5. See, it doesn't really matter to us. We use calculator. So we have something like 32,768. Okay, 768. Well, so looks like now we're going to get the actual exercise 11 workout. Finally, all right? Alex, I've been waiting for this. Well, thanks for your patience. Now we're there. So we do exercise number, maybe here, 11. That gives us number 70355 in the base 8. Okay, 70355. I write it wider so I have room to insert all these powers of 8. It turns out this is pretty mechanical procedure because I don't really care what those numbers are. I just insert the powers of 8 and then I'll put this all in the calculator and we'll be done with the exercise. That's the whole point of story. So this is pure calculator exercise because you definitely don't want to by hand deal with these powers of 8 with such nasty numbers of 4,000, 512. So it's just a little too much. Oh, looks like I didn't really need the 5th power of 8. I just find with the 4th. Well, that's okay. So here's what I need to calculate. So please notice that this guy is multiplied by 0, so that'd be 0. So I don't really care for it. But the rest I need to put in the calculator. I say, Alex, what if I put that 0 also in the calculator? Fine, you can do that. Doesn't matter. Calculator will take it. So my calculator is here. So let me go ahead and start multiplying. So I'm gonna have 7 times 8 to the power of 4. So I just enter it the way it is. You can actually put 4096 if you want, but technically it doesn't matter. Plus, now that 0, I'm not going to enter because it's still 0. Now 8 cubed, right, will be multiplied by 3. That's the next piece. Then we have 5, which is actually 8 cubed is missed. It's 8 squared. Sorry, it wasn't 2, right? 8 cubed is actually times 0. So 8 squared times 3. Okay, now it feels better. Plus 5 times. So I just need to carefully enter this entire line that I put for exercise 11, because technically at that stage it was done. And then I multiply this by 8 to the power of 0, which is 1, right? I say, what if I enter 8 power of 0? We can do that if you want. So there we go. The answer here is what our calculator gave us, 28,909. So in the base 10, so we don't put 10, the number they had, let's see, where is that number? Well, I better just go back so you can see it here. So the number we had, which is 703 and 55. So in the base 8, when I say, oh, that's like 70,355. Well, but that's in the base 8, so it's not really the thousands. It's 7355 base 8. Because we don't have 1,000. It's actually 7 of these guys, 4,096s, and 0 of that and that. So it's not really 70,000. It's a 7 of these, 0 of these, 3 of 8 squares, and so forth. So it's really not 70,000. It's in the base 10 will be 28,909, but it's actually base 8. So it's pretty unusual, one can say. I know, but I guess that's the subject matter of this class. And I think that teaches people how to do some abstract thinking without really basing it on some of the things that you already learned before, because people usually trying to relate it to their past experiences, but there's no past experience. So let's say you get into a different planet where everything is totally different. So you cannot use your past experiences in order to operate in totally new environment. So it could be totally different. So this is new environment. So you cannot really use base 10, some ways of thinking. All you do is just utilize what they told you as definition. And definition is powers of 8. So that's basically all it is. So it's no longer the number that you used to see. It's not 70,000. It's 70355 base 8. Just like that. I know it's hard to comprehend when you say, well, that's just like in a science fiction movie. Yes, that's true. But hey, we're in new normal right now, right? They say. So that's new, totally new. So that's something that, who knows, might be somehow helpful somewhere eventually. So anyways, I'm trying to find another number base 8 here. And I don't see it. If I can get one, there's only one base 8. Well, let me try base more than 10. Let me, for that matter, take a look at what they recommend. Last time we saw Mayan way to write numbers base more than 10 with these symbols. And of course, it'll take you forever to get used to those symbols, because that's another different thing. So that's why they just working with other bases, such as bigger than 10, such as 11, 16. I think I saw an example here. So that's base. 16. You see, example 3. So what they say that since you're dealing with a base larger than 10, then according to my previous observation, with base 8, we should have only 8 digits. With base 10, we have 10 digits, right? 0 and then 1 through 9. But in the bases bigger than 10, we need to have more than 10 digits. So what be the digits? So they recommend to use these 4 digits. In other words, digits will be the following. Digits are 0, so that's 1, 2, 3, 4, 5. Alex, I know those. 6, 7, 8, 9, but we need more. See, if base is 16, you need to have 16 digits. You have already 10, so 6 more. And they say put A, B, C, D, E, F. No, it doesn't fit. Let me break this down. Base will be, so digit will be from A to F, those that correspond to actually 10 and so forth. And that's another thing to start wondering, how come? Well, again, we're using analogy here with the previous basis. See, you think by using the analogy with previous ways of thinking. So that's base 16. In other words, letter F, or actually now it's digit F, in the base 16 stands for number 15. See? Or digit C in the base 16 stands for number 12. Because once again, we have to have 16 digits and they all describe those numbers. Just like in the Mayan, remember, numeration, we had digits from 0 to 20, and they all look different compared to Arabic digits that we're using in today's world. But in their world, they used totally different digits, and they had plenty of them. Looks like now here in Arabic digit world, we don't have enough digits. So we need to create 6 new ones to get to the base 16, and that's what we just did. Actually, they did. I didn't do it. They did. And if somebody says here in example 3, convert this to the base 16, convert this number to the base 16, then you're going to use powers of 16. So it'll be 16 power of 0, whatever it is, 16 power of 1, and then 16 power of 2. So it's analogous to what we just did with base 10. So we were using base 8, right? I just did exercise in the base 8 right here. There you can see it. So we had this exercise and we had powers of 8. So now I'm going to have powers of 16. So since I have only 3-digit number in the base 16, well, I don't need the higher powers. So I'm going to just put this 7 plus, this will be C. Notice that C is actually 12. So it'll be 12. I say, Alex, why don't you put C? Well, because I cannot put in my calculator. So, and finally, E, which is right there, it's 14. And that's your number. So you can put it in your calculator and calculate. Let me do that. See the analogy? Now we don't care, it's just powers of 16, and whatever digit it is, well, we ran out, so we put this E and C, they stand for those two. Then we just multiply them by various powers of number 16, and let us do this. So I'm gonna have 14 multiplied by 16 squared plus 12 times 16 power of first, so just 16, and finally plus 7 times 16 to the power of 0, that's 1. So it's just a 7. And there you have. So if you have a doctor's appointment, that's fine, I guess. But yeah, you could do even exercise to make up for the quiz. I will, of course, give you a point for being present today, but you could still do even exercise and make it up for it. That's not a problem. So 3,783 is what it is. And it's actually written in the form EC7. That's an unusual way to write numbers. Well, because we don't have enough digits. That's the issue we have. EC. See, Mayans, they took care of it. They actually had plenty of digits, but us, we don't. But we can use alphabet, letters of alphabet. So they found a way out. So let me try another exercise in the base 16. And as I said, I will give a quiz at the end. I say, who is on this? I'll give you something that is reasonable. Maybe I can give you something in some nicer base, not 16. I know 16 is a little bit too much, right? Some nicer base. Let me do another exercise in the base 16 since we started with this. So get to next pages. See, to get from page to page here, you need to click one thing, click the other, and click third. It's not that simple, turns out, but eventually I get there. That's good. So I just saw some other exercise in the base 16 here, like this one. So let me try number 18 and see how can I possibly put this down in the base 16. Oh, somebody asked for 29. I'll do 29 later because that's a backward conversion. That's actually a good idea. So see, I need to better monitor this chat. So I'll do 29 later. So let me finish up with this type of exercises, and then definitely we'll do one you like. I think that's very good idea. So let me first do 18. That says EDF7. So it looks like the powers of 16 that will participate in this process will be 0 for the last digit, right? I prepared them. First for the previous, then there's a second power and looks like the third power, right? Third power. Okay. And then we have this thing, which is E. Maybe I can put this in other color. E, D. I put them above because I want to rewrite them with actual Arabic so I can put them in the calculator. And then 7, right? So it looks like 7 is fine. I can just use 7. 7 is something calculator will definitely take. What's in front of 16? Well, look at what I copied here. See, I was prepared. It's a F, which is actually 15 in our system base 10, and so forth. So D is going to be after 12, which is 13, right? D is 13, so I put 13 times that 16 squared thing. And finally, letter E, which is 14, right? And that's it. That's what I put in my calculator. So we get that. So I hope that you start to get the feeling that these problems really asking you for pretty much the same procedures. You just write those digits of your number, but they all multiplied by powers of whatever base you have. If base is 16, they multiplied by powers of 16. Okay, so what? Just multiply. So 16 should be cubed The next we add is 13, which is going to be timed by 16 squared, right? Plus the next is 15 times 16 to the first, so just times 16, and finally plus 7, because 0 power is really nice. And then here's our answer. You say, oh, 60,000. See, I don't really care. They're just random numbers they throw on us. So we just get some kind of random answer. So there's really not much of a relationship. Okay, so now we'll come to the part that you were asking finally. I know it's been a while, but eventually we get there. That's a good thing. Better than never. So I was asked to do 29, I guess, right? Yeah, 29. Since it's way too messy, maybe I can clean a little bit here. So you better see what's 29 is. So it looks like they're talking about base 4, right? In exercise 29. Okay. So since it's base 4, then we deal with powers of 4. So for problem number 29, why don't I prepare some powers of 4? So what I'm going to do is get, of course, 4 to the power of 0 on the first place. It's 1. I say, Alex, you really like these powers, looks like. You're always into them. Well, yes, so we can better see what is really going on here. 4 squared is next, which is 16, right? And looks like I don't need any others because the actual number they have is 13. So 16 already exceeds it. Okay, so 13 and the base 10. How can I rewrite it using powers of 4? So definitely not 4 squared because 16 is already bigger. So now you see how many 4s will fit into 13. When you say, well, 3 times 4, which is 12, right? And then 1 will remain. So 13, I write 12 as 1 and 1. So I'm utilizing this powers of 4. So that's the idea. So first digit, so let me put that 4 to the power of 0. And this is 4 to the power of, actually this is 4 to the power of 1. Sorry. And that's 4 to the power of 0, right? So now what I have here is the 3 for the first digit and 1 for the second digit. And that's in the base 4. And that's number 13 base 4. And if you don't believe it, then you just write 1 will be multiplied by 4 to the first power plus 3 will be multiplied by 4 to the 0 power. And that's exactly what I just did up here. So we have, oh, not, sorry, it's 31. So what do I do? I guess I got carried away again. So it's 31. It's called dyslexia sometimes when you switch the numbers around. That's very disappointing. I need to check with the doctor. So 3 is here, right? So it goes here. And 1 is here. I somehow switched. So it's 3 times 4 to the first power, which is 12. And 1 times 4 to the 0, which is 1 times 1, which is 1. So 12 and 1 is my 13. So let us do another one here. Let us do another base 4. So we get used to this. So I don't jump from base to base. So let me try this one, 36. I see another one, base 4. So let me do similar problem. It's just a little different number. And again, I need some room for this. So it looks like on that little page, there are quite a few exercises we have, right? So let me prepare. So base 4. So problem number 36. It says 199. Write it in the base 4. Please notice this number is in the base 10. So now I need to write it with powers of 4. And since I already have a couple of powers of 4 prepared, such as a 4 squared. Now I also can utilize 4 cubed, right? Which is 4 times 4 times 4, that's 64. I say, oh, Alex, 64 will nicely fit into this. Yes, but I still want to make sure that I don't have higher power of 4. So let me get 4 to the power of 4, which is 256. I say, how did you know that? Well, it's 16 times 16. I remember it's 256. So please notice that 256 is already over than 199. So I don't use this 4 to the 4. So I just need to see how many 64s will fit into 199. So in the book, they say just divide 64 into 199 and see how many times it fits there. And 6 times 3 is 18. So I think 3 times. Let's check it out. 4 times 3 is 12. So I carry 1. And then 18 and 1 is 19. Good. So 7 remains. So what I see, it's already 4 to the power of 3, 7 times. Plus. And what? Oh, sorry, 3 times. Why did I put 7? 3 times. The quotient, right? 3 times. And 7 is still a remainder. So now I need to write 7 using powers of 4. And notice that 16, the lower power, is not working because it's too big. So now I use just the 4. So how many 4s fit here? Well, just 1 4, right? And then plus 3. So what I have here is 4 cubed. I think I should be using the different colors so you better see. So 3 was multiplied by 4 cubed. 0 is multiplied by 4 squared because there is no 4 squared. Then there is a first power of 4 and 0 power of 4, right? So we have here 1 4, right? Just 4, and 3 ones because 3 is multiplied by 4 to the power 0. Those are 1. So that's the number I split using powers of 4, and the number is, I just put green ones, 3 0 1 3, and that's a base 4. Again, it's not 3000, it's 3013. It's actually 3 of these guys, 4 cubes. It's 3 of what's 4 cubes? 64s, and no 16s, and 1 4 and 1 and 3 1s. I know it's different, but what can I say? So powers of 4. How about get to powers of 2? Let me write something like number 26. So I'm gonna clean this a little bit. So I will be giving you quizzes, probably the nicest exercises. So that's why you're free to choose anything you like for extra credit, because I don't really expect you to do some hard problem to make up the quiz exercise that actually was nice exercise, right? So anyways, let me try one with base 2. So let me try 26. It says write 6, convert 6 to something in a base 2. So in a base 2, we have powers of 2, right? Remember, to the power of 0, to the power of 1, to the power of 2, and so forth, to the power of 3. So this is 8, this is 4, this is 2, and this is 1, as usual. So now I need to split 6 with some of these numbers. So it looks like 8 is not working. I have 4 that appears here, right? And also 2. So I have 1 4 and 1 2. So this is for 2 squared. This is for 2 to the power of 1. And for 2 to the power of zeros, we don't have anything, which means we have 0 of these guys, right? Nothing, 0. So if something is missing, that's a 0. So that's 0 of it's 2 to the power zeros or ones. So here's our number, 4, 2, 1 base 2. Oh, sorry, not 4 to 1, 1, 1, the red ones. Say that today just need to be a little bit more concentrated. So the red, I put them on purpose. Red. Get there. Red. So it'll be again 1, 1, 0. Right? And 0. And base 2. So whatever coefficients we have with these powers of 2 is what I put in front. 1, 1, 0. And the base 2. So would you like to try to write? Let me give you something pleasant. Write number 2 in the base 2. Number 23 for a quiz. For today. So write number 2 in the base 2. So it should be a bunch of ones and zeros, right? Ones and zeros. So what's 2 in the base 2 is equal to? Please notice there is no such a digit as 2 in the base 2. There are only 0 and 1, right? So I'm gonna stop recording. And I hope